Hello, you absolute legends. This is a quick talk about the unit of rate law and rate formulas in the chapter of kinetics. Big things I want you to understand about the rate law. Its basic format, the units and arrangement of all the numbers that are present in there, how to calculate individual entities and rearrange that reaction. This is a generic format of the rate law. The rate of anything is over time. Lowercase k is a rate constant specific for every individual reaction, has an individual rate constant. The molarities of the reactants to an exponential power that we call the order of the reactant. Now this is a rate law for things that have, see this dot, dot, dot here? You have as many as there are reactants in the formula. If there are two reactants, there will be two things here. If there is only one reactant, there will only be one thing there. You need to understand how to calculate, the order of each reactant by choosing experiments wisely. If you have two reactants, like in the labs we have done, there are 3 experiments and you choose 2 experiments based on the concentrations that are planned and prepared. If there is only one reactant, really any 2 experiments will do. You have one reactant where the concentrations change, and we just measure and observe the rate here. Make sure you can choose your experiments. After choosing your experiments wisely, you will set up your proportions carefully to solve for the order with respect to that reactant. Experiments chosen wisely, see how we have the molarities equal to the rates from the experiments, and we put this in here over the molarities. Why is this red exponent on this side and not this side? Why? Because of the format of the rate law. We have exponents over molarities. Logical, it should be on this side of the equation. Make note of that when setting up. It's an easy mistake. When you have the order of the reactants calculated, you can choose any experiment and calculate the lowercase k, the rate constant. Because from any experiment, you will have this number, and this number, and you will have that already calculated. So rearrange, solve for lowercase k. The units of lowercase k is different for every single reaction. You have to retro scaffold it out, making sure that the units on this side of the equation match the units on this side of the equation. Lowercase k will always contain time in the the denominator, and 1 in the numerator. To calculate the fast and the furious of the future, this is a situation where I want to plan my time appropriately. I want to choose the rate or how fast this reaction is going to go. If I know this, know this, know this, know this, know this, I can calculate the rate. What is the future? I hope this helps. Thank you.